your worksheet in front of you? Okay.
Yes.
Okay. So let's look at this. And if you guys want to write on this, you're welcome to. Okay, so we have a piece of cardboard and the dimensions of the cardboard. So not the dimensions of the box, the dimensions of the cardboard are 12 inches and 18 inches. All right, and we want to make a box that has a volume of 224 cubic inches. All right, yep, and you guys are welcome to draw on here. So volume of 224, that's very important. The cardboard has a width of 12 and a length of 18. And whenever I see units and it's referring to an object, I always go and locate that on the image, on the drawing. So where is 12? Here it is. And here's your length of 18. And notice it's that whole length across. Okay. And the volume is 224. So remember when we're talking about volume of boxes or rectangular prisms, our formula for volume is length times width times height. Good. Okay, we don't want to label those quite yet because we are making, good, I like your question mark on that up and down. I agree with that. Remember, the length of our box is not 18. The length of our cardboard is 18. So we're actually going to be cutting these squares and we're going to remove them from the box. So then we will tape up, then the side of the box, and then we'll make our box that way by folding those up. So so the length is not going to be 12. The maximum, the length will be, or excuse me, the maximum, the width will be is 12. The maximum, the length will be is 18, but we don't know what they are. And that's actually what we're going to be doing here in this project, is figuring out what are the dimensions of our box that end up with this volume that we need. Okay, so this worksheet lays out the steps to go. So let's look at part 1. Each dimension, the width, length, and height. So look at width, length, and height. Look at, we need those in our volume formula. Awesome. Okay. Of the finished box can be represented by a polynomial expression. So what they're saying is we're going to use algebra to represent this situation because there is enough that we know about the situation that we can write an equation, and we're only going to have one unknown in that entire equation. The only unknown we're going to have is x, which is representing the height of these little cups. All right. So if the height is x inches, what is the length in terms of x? So let's label each down here on part 1. So our height is x, our width. So notice the width of our box here is 12 inches minus an x. We're taking an x length there and an x length there. So 12 minus x again. We can combine like terms. Good, is equal to 12 minus 2x. Good. Okay, and we're just using that to hold our place, right? Okay, so now let's do the same thing then for our length. So this longer dimension. So we're going to start with 18 minus, we're going to subtract a length x here and a length of x here. So minus x, 18 minus 2x is our length. All right, nice. Thank you for throwing that in there. Okay, questions with what we have now?
What about the other side of it?
What side? Could you draw?
Yeah, here, let me. This side.
Good question. What is the length of that side? So we know the properties for rectangles that they have opposite and equal sides. So whatever the side is over here, 18 minus 2x, it's the same length on that opposite side, 18 minus 2x. Good. And so this right side length is 12. I'm going to change the color just so we're consistent. We can match. 12 minus 2x is that length right here. That means this length right here is also 12 minus 2x. So that length that we drew in with green there represents this length. It's the length of the box. And I'm gonna go in orange, just draw in the length. It's just this segment right here. Okay, does that help? So we have our properties of our rectangles. Okay, I'm gonna clear the writing. You guys are good? Just have to move the worksheet.
I'm good.
Okay. Okay. There we go. Okay, and then let's write in our info there. Okay. Okay, and our length was 18 minus 2x. Okay, so we know the formula for volume is this. And what was our volume again of our box? They told us the V equals
Volume.
Very good. And what is the volume of our box?
I think it was like 243 inches cubed.
Is it 243 for sure? Did you just look at your worksheet?
No, I didn't. I'll look at it now.
Okay. 224.
Okay, that's
All right.
close.
You were close. Good. So 224 units cubed. I don't know what the units were. That's not important. Okay,
It was
224.
inches.
Okay. So we know, we now know an L, we know a W, and we know an H. And it's okay that we don't know exactly what numbers they are because they are all related to one another by a common variable, X, the height of that box. So we're able now to write an equation with only one unknown. The unknown is going to be X. So let's go ahead and do that. So V equals length times width times height. And let's substitute in everything that we know. What's our V? Oh, there's our V, 224. 224 equals, what's our L? 18 minus 2x.
Yep.
Okay, now notice there's two terms there for L, so we're going to keep that in parentheses. Our width, our W, 12 minus 2x, I'm also going to put that in parentheses, times our height is x. So look at, we have three terms being multiplied by one another. Good, and Katie put in multiplication signs in between, which you can put or not put. When parentheses are touching, that implies multiplication is happening. Good, okay. So we have written our equation, and what does it say? Simplify on the right side by multiplying the polynomials and writing the answer in descending order. Okay, so we need to multiply the polynomials. We're going to write our final answer in descending order, which we talked about last week, and then
You can do those two with the FOIL method, right?
Perfect. Because we have a binomial times a binomial, we can do FOIL for those two. Good. So go ahead and do FOIL for those first two terms. First, inner, outer, last. Okay, and Malachi, I want to make sure that you're doing okay. So pipe in with any questions or if we need to go slower or whatever. I know it's hard sometimes though to do Zoom and write math. All right, so we have 216 times. What are you going to do next there? All right, and where
I did the X also.
Okay, let's just FOIL first. So, okay, let's break it down. We're going to just do all the steps. Okay, so first, 18 times, changing my color, 18 times 12. What'd you get for that?
I got 216.
All right, so 216. Okay, and I'm going to change my colors for each one just so we can keep track. Then we're going to do 18 times negative 2x. So 18 times negative 2 is negative 36 x. We okay with that?
Yep.
All right. Inner is a negative 2x times 12. So that's going to be a negative 24x. Last, negative 2x times negative 2x is a positive 4x squared. All right, so really important here that we're showing the initial 4 terms from our FOIL. And then bring down this x. We haven't used that x yet. That x is still being multiplied on the outside. So first step is to simplify what's inside those parentheses from your FOIL. Good, you're doing great. So you're going to combine your x terms. Good, there's that 60x, good. Plus 4x squared. Beautiful. All right, and we still now
It's not in descending order yet though.
Good. And it's okay, we don't have to do it yet because we still have to multiply everything by x. So now our last step, go ahead and multiply everything by x. I would even go backwards here because then you could do your largest exponent term first. So 4x squared times x is 4x cubed, good. And then, good, times negative 60x squared. Good. So we're adding our exponents together on this step. Good. And then good catch, Katie, making sure that you final answer is in descending order. I can do that real quick here. So final answer, I'll do it in red, 4x cubed minus 60x squared plus 216x. All right. Every piece of that is super important. The negative in front of the 60x squared and your exponents. Okay. I'm going to write that down, make sure we use it. Okay, so reminder, this expression right now is just holding space for the volume of our box. This is representing the volume of our box. That has a height of x. Okay, all right, so I'm going to clear this off. All right. If I leave it that small, can we see it okay? We can get the rest of the worksheet on there. Is that okay? Okay.
Yeah, I can see it fine.
Okay, good. All right, so I'm going to write our expression here. So our expression for volume, remember, volume is equal to 4x cubed minus 60x squared plus 216x. Okay, part 3. The length of each cut at the corners is represented by x. To make a box, x must fall in a certain range of values. For example, x cannot be 15 because that would make the flap longer than the width of the box. Identify one reasonable value of x. Why did you choose that value? So let's go back here and look at our picture for a minute. Let's each brainstorm. What's a reasonable value of x there? Has to be smaller than notice we have an x on each side here. So could we have, for example, let's try this.
It has to be smaller than the length and the width and the height.
Okay. Could x be 7?
Yeah.
Okay, let's test it.
Probably.
Let's test. So we have a 7 there and we have a 7 here. Because remember, we're taking out of both sides of that length. 7 plus 7 adds up to
14, so that couldn't work.
Could not be. So how does that help you come up with reasonable values of x?
You know it has to be at least under 7.
Okay, yeah. So half of this number, less than half of this number. Okay, would 5 be a reasonable? Would 5 work? Five would give us a height of what? If x was 5, our height would be 2, which is fine. Would it work over here? If we took 5 away from each side of that 18, you're left with 8 for the length. That works, right? As long as you're left with a positive number. That's what we're looking for, because remember, those are representing distances. Okay, so 5 works. And I like how you said that. Basically, anything smaller than 7 will work. Okay. So my touch screen is not working. There we go. Okay, so you guys could each pick your own value that makes sense. And then here's where you get to explain why, okay? So why did you choose that value? And so that's an opportunity for you to show that you're understanding. Okay, so now part 4. Use the polynomial equation you wrote in part 2 to find the volume of the box for each value of x. Show your work. All right. So we're going to substitute in these values, and we can do a couple of them together. So if x is 0, what's the volume of your box going to be? And here's where you want to be showing your work. So if x equals 0, your v is going to be equal to 4 times 0 cubed minus 60 times 0 squared. Good, plus 200. So Katie, you noticed quickly, if we multiply everything by 0 and we add up a bunch of zeros, we're left with 0, which makes sense. Because have you guys ever seen a box with a height of 0? What would that look like?
It wouldn't exist.
It wouldn't exist. It's like a piece of paper. Okay, in order to make a box, you need to have a height. Okay, so go ahead and let's do another one together. We can substitute in Now look at what happened there. Let's do 6.
Well, it could
together.
exist if it had no height, but it would be two-dimensional.
Good. Yep. It wouldn't have a volume, right? Let's look at what happened here on 6. When x equals 6, how is that possible? How did we get to 0? Let's test that out.
Everything probably cancels out.
Visually, what does that look like if our x value is 6? Go back to that drawing that we were just playing with. And I think you're right. Everything does cancel out. Remember, what was the length of our paper on one side? Our shortest length of our paper was 6.
6 plus 6 equals 12.
12. 6 plus 6 equals 12. Yes, so that is a big conundrum. If I cut away 6 inches in one direction and then 6 inches in another direction, I don't have this 12 anymore. I have nothing left. This whole side length again is 0, which means we're left to something that's a two-dimensional shape. All right, so I'm going to let you guys substitute in the remaining, making sure you're showing your work, okay, for those ones. And remind me, what are we looking for? What's the magic volume we're looking for?
224.
224. So we are looking for the x value that gives us that. Now, technically, it doesn't have to be a whole number length, but I'm assuming that it will be a whole number length. Okay, so this is our goal here. This is our target. And then you'll answer based on your table, what x value created. Okay, then your last step, once you figure out what x value makes the volume of 224, you're not done. Then you have to go and describe all 3 dimensions of your box. But have no fear, because remember, your width, you had an expression for. Your width was 12 minus 2x. Your length was 18 minus 2x, and your height is x. So, oh, why does that keep getting a pop-up that's stopping me from writing? All right, so width, I can't write on the screen down there. Height equals x, and then, so this is your width. And your length equals 18 minus 2x. So your last step is you're going to substitute in the x value you find from up here to figure out your 3 dimensions. Okay? Okay, so there's the path to follow to come up with that final answer. At this point, you're just left with some number crunching to do. Okay, so what questions do we have? Does that help on the worksheet?
Yes, thank you.
You are welcome. Okay.